So this was the question which we trying to solve, but because of some reason we could not, and after looking at it nicely, I find out the reason why we cannot solve this question is this. I made a mistake in minus, okay, because of which I could not solve this. Here is the main reason, culprit. This is the main reason why I could not solve this question. So this time I hope that we will not do the same mistake. So let's copy the same question and try to solve once again with a fresh mindset. Copy. Sorry. Paste. Sorry. So I have marked up everything. Now let's try to understand one by one. So first thing first, this one first minus, that is RPPM minus RPPM QTPA. If I minus, how much I am getting? QDA. So if I look at this one, so what could be the possible value of M? M either could be 2A or M 10 plus M. See, here is actually what I am trying to write is M minus A equal to A. So eventually it will be becoming M equal to 2A. So in this case, when is this case happening? When M is greater than A, and when M is less than A, so M will be taking one carry over here, so one carry will be becoming 10 minus A equal to A. So here my equation will look like something 10 plus M equal to 2A. So these are the possibility. Okay, these are the possibility. So in this case, in the first case, let me just write it here. In the first case, if M is greater, I can say P minus P will be 0. So in this case, my D will be going to be 0. Okay. So first of all, let's think of this case 1. If my M is greater, so it will be 2A. P minus P will give D as 0. Then comes P minus T equal to Q. So one thing, if I notice correctly, that P minus T equal to Q, after that what will be coming? R minus Q will be equal to 0. So in the question it is given that all the in the question, if I read the question again, all the letters represent distinct digits. So if P is already 1, so Q cannot be 1, it has to be different. If P is taken as 1, so Q can be anything except for 1. So if I use that concept over here, I can say P and Q are two different digits. But what I can say, that in this case what might have happened, that R is giving 1 as carry, and then one more equation will going to form in this one, that is 10 plus R minus Q, 10 plus P minus T equal to Q. Okay, or either way I can write 10 plus P equal to T plus Q. Okay, this is one. this is second, and this is the third. Everything happening if I know the value of m. Okay, and then r, if r give one carry, then q will be 0. So I can say rightly that r minus 1 equal to q. So here I can find a very good possibility of q. Okay, so this much is done. Let's think of the condition when p is greater than. In that case, if m is less than, so what is going to be happen? M will taking one carry, and for p, what will be happening to p? P minus 1 minus of p. So if p is giving one carry, so p minus 1, it will be becoming p minus 1, right? P minus 1 minus p. Again what will going to happen? It will be giving me minus. So what will going to happen? That this p will take carry. So again what will going to happen? 10 plus p equal to becoming d, right? Because p minus 1, when p gives 1 as 2m, it will be becoming p minus 1. So p minus 1 minus p, it cannot be possible, it's a smaller number, so it will take carry from this p. If it will take carry, so it will be becoming 10 plus p minus 1 minus p. So this p will cancel, and the value of d will becoming 9. So in either of the cases, we can certainly, if we can find this relation, which relation is correct, then we can find the value of d. D will either be 9 or d will either be 0. This is the only possibility of d. Okay, so my d, either it can be 0, either it can be 9. There can be only two possibilities. Okay, let's move on. So as of now, we know that this p has given 1 as carry. So how much this p has become? This p also become p minus 1. This p also become p minus 1. But then again, I know that for here to be 0, r has to give 1 carry. That's only, this is a possibility that r minus 1 equal to q in this case also. So r will be giving 1 carry, so it will be eventually becoming 10 plus, what is p minus 1, right? 10 plus p minus 1 minus t equal to q, it's right. So eventually it will be becoming 9 plus p minus t equal to q, and at the end of the day, r minus 1 equal to q. This is r minus 1 equal to q. This is same in both the conditions. Let me just give it a good shape, because this is true in both the conditions. So this much is for sure. So as of now, I could able to find different equation based on the one cases. Okay, let's move on to the next minus part, which is this much. Copy, let me bring it here, paste. So first thing first, d minus s equal to m. Okay, d might be greater than s, might be less than s, so we are not going to comment over here as of now. Let's come to the a part. So I can say, what could be the possibility a minus p equal to p? So what I am seeing over here, that q minus p is becoming 0 and d minus p is becoming 0, and I know q cannot be equal to p and my d cannot be equal to t. These are the two things. So these two has to be different numbers. So these two has to be different numbers. So last time I made a mistake over here only, that what is a possibility that 57, 46, okay, two different number, but can I get 0 over here, or what? Either 0 or one more thing can happen, that it will give 1 as a carry. So 1 as a carry, so either this 0, or 56, 46, can it be 0, 0? No, it's not 0, it could not be 0. So what is the possibility when it will be 0, 0? So the only time it will be possible when it is in the term of 60 and 59. Not only 60 specifically, I am saying 80, 79. It has to be in, this has to be multiple of 10 and this has to be minus 1. Only in that case what I will, what is visible. Let's take one example. Let's think 60 minus 59. In this case 6 is not equal to 5, 0 is not equal to 1. But once if there is number like smaller number, if I give 2 and here give I 8, what is happening? This is giving 1 as carry, so here it will becoming 0, but at this point it will be becoming 4. So this is the same type of cases. So if this type of cases is there, so what I can say for sure, that my value of D is surely, my value of D here should be surely 0 and my T should be always 9. At this point I cannot comment, but because it might be 6, it might be 5, anything. But one thing I can say, looking at this 6 minus 5 always 1, 8 minus 7 always 1. What I can say here, one more equation I am finding out, that is Q minus P equal to 1. Okay, so these two things we have found as of now. So as we got the value D equal to 0, T equal to 9, let's write it down. D equal to 0, D equal to 0 and my value of T equal to 9. So I can replace all the values over here. My T 99 it will be becoming 99, here it will be becoming 9, here it will be becoming 9, 0, 9. D will be how much? D is how much? 0. Okay, so my D is becoming 0, and here also D is becoming 0. Okay, so as of now this much is done. So one thing I will say, that this equation and this equation, if I look at this one, I will say that P equal to, if this one I can say P equal to, or let's say Q equal to P plus 1, right? And here I will say that R equal to Q plus 1. Okay, so if can we say that P, Q and R, these are consecutive, because P plus 1 is Q, Q plus 1 is R. So one thing which I found out, so let's just, okay, so what is we got at, let's just write over here, or let's just we can write anywhere, let's just write here only. So P, Q, R, they are consecutive. Okay, this much we found. And again we remember that the value of D equal to 0. So I will say that if value is D equal to 0, which is possible here, so this equation is wrong. So which means M is greater than A. So M is greater than A. This much is also our finding. This is also our finding. And again T value 9. So if I replace over here, so I will get the relationship between P and Q, and P and Q relationship we already know, so we don't need this equation also. We don't need this equation. We actually, after this, we don't need this equation. So whatever equation we don't need, we will just cut it, so that we don't have to bother. This also we don't need. This also we don't need. So M equal to 2A. This is also equation which is helpful. M equal to 2A. This is the equation we got, or we need. As of now, what are the convenient equation which we have formed as of now? So the value of, so any equation which I have found, no, okay, no, it's fine. So now that I know D value is 0, so I will replace it with 0, and T value is 9. My T value here is 9. Okay, or let's just change the color so that it will be easy for us to spot. So in this one, D equal to 0, D equal to 0, T equal to 9, D equal to 0. Okay, so let's just see in this equation only. So what is happening? 0 minus S, then it's becoming M. So one equation, one thing I can think of it, that A will be giving one carry, so 10 minus S equal to M, so 10 equal to S plus M. One more equation I got, one more equation. Let's write 10 plus 10 equal to S plus M. Okay, 10 equal to S plus M. So, and then one more equation I am getting after this, that if here is 0, here is 0, and I know that A is giving one carry, so how much A is becoming? A is becoming A minus 1, A minus 1, and I know that this is also giving 1 as carry, plus 10 minus P equal to P. This is also one of the equation which might be helpful, or which we can get it. Let me just give it a nice, yeah. So if we solve this equation, let's write nicely now. A minus 1, so I will just write it here. A minus 1, A minus 1, then plus 10 minus P equal to P. So I can rewrite this as A plus 9 equal to 2P, right? I can write, can I say this? A plus 9 exactly equal to 2P. Let's just write A plus 9 equal to 2P. So as of now we got a lot of variables in M, and then P, and A. So let's just try to utilize, or let's see if we can get any value from here. So P minus P, grade 0, understood. P minus 9 is Q, so there is nothing we are getting from here. So if still we cannot solve, then we will move on to the multiplication part to see if we can utilize anything. So if I look at this point, can I say that 2P is 2P, it will be even. If this is even, then this part will also be even. So odd plus odd is even. So I can already filter what are the values of A. So our A can be 1, 3, 5. Okay, one more thing, that A cannot be 5. Why A cannot be 5? That is a very good question. The reason why A cannot be 5 is, if A is 5, then 5 plus 9 is, okay, oh no, A can be 5. A cannot be 7, I guess. A can be 7 also. Okay, what A cannot be then? Let's see what A cannot become. Okay, yeah, correct. So yeah, it's true, A cannot be 5. So the reason for A cannot be 5 is, if A is 5, then 5 into 2, 10, M cannot be 10, because there is only one digit. So more than 5 is not even possible. So the possible value of A are 1 and 3. So let's just write A equal to 1, A equal to 3, and let's take all the possibility. So if A equal to 1, so 10 P will be equal to 5. P will be 5. If P is 5, Q will be 6, R will be 7. So P, Q are already done. So if A is 1, then M equal to 2, and if M equal to 2, then my S will be 8. S will be becoming 8. So everything as of now till here is filled. Okay, let's think of, if A is equal to 3, then how much will be P? 9 plus 9. If A is 3, then 9 plus 3, 12. So P will be 6. So my P will be 6, Q will be 7, R will be 8. If my A is 3, then my M will be 6, which is again not possible because P 6. So again this is not possible. So whatever the value I received over here, this is a correct value. So if I see my A equal to 1, my P equal to 6, P, Q, R equal to this one, my M equal to 2, Oh wait, P, oh okay, I made a mistake. P equal to 5, Q equal to this one, S, and 3 and 4 are only left, that we can, that is between N and what is left, N and only N is left, right? Okay, we can solve. So if that is the case, I can write as A is 1, my A is 1, and my R is 7. So 7 into what, the last digit will give me 1, so only possible is 3, because all the digits are already been taken. 4 I will take, it will be 8, so my N will be 3, my N will be 3. This is the answer. Anything left? No, I don't think so anything left. So this question is done. So last time also we were on the right path, but the mistake we did is at this point, that we could not able to understand the meaning of this question. Here is 1, so that is what I made a mistake, but in the question it should be 0 0. So here already we have to understand, I took this condition, but over this point I got confused, because of which I took a lot of possibility and I made mistake. So yeah, this question is done. Now we will solve one more question. So this is also one question. Let's read first the question. There are 100 bulbs that are switched off in the long corridor of a hostel. So there are 100 off bulbs in the corridor. The first person comes and changes the state of the 100 bulbs. So what does this mean? That if they are switched on, switch off, and vice versa. Okay, if it is on, first person will come and change the state. State means if it's on, then he will just turn off. Okay, and if it's off, then it will be on. So the second person changes the state of every second bulb. Okay, so if it's one like this one, so first person changes and then second person change second bulb. So the third person changes third, so third person changes third. Okay, great. And the 100% changes the state of the 100 bulbs only. Note, each person start doing the changes after the previous person has completed the job. Okay, so the question is asking, first question, how many of these 100 people would have changed the state of the 90th bulb? Okay, great. 90th bulb we have to find out. Then at the end of 100th operation, that is after all the all have done their job, how many bulbs will be switched on, assuming all the bulbs were switched off initially? So assuming switch off, then how many are still on? Great. The third question is, if the operation would have been stopped when the 50th person completed his job. Okay, 50th person completed his job, and how many bulbs would have been switched on, assuming all the 100 bulbs were switched off initially? Okay, so great. If the 50 bulbs were switched off and the next 50 were switched on initially, then at the end of 100 operation, the state of how many bulbs remains unchanged. Okay, first of all, let's try to understand the question, what it is saying. That let's just think that this is the lane of the hostel. Let me make some. Okay, it cannot be possible. Let me make freehand only. So in the question, in the beginning it is said that all the bulbs are switch off. Okay, so first all are switch off. First person will come and switch on. So switch on, I will give this sign. Okay, it will take a lot of time, so let's so on. Okay, I have just make few because of the time constraint, but so on with all the bulbs. Paste. all the bulbs, this is what is happening. Okay, so till here going. So after first person did this, the second person, what he will do, the second bulb, he will change the second bulb only, and the state of it will change, he will change the state of the bulb. So on. Third person will come, he will change the state of the third one. So it was on, so this time it will be off. So first, second, third, it was off, so he will just turn on now. And first, second, third, it was off, on, so he will turn off. So likewise. So what I am trying to find over here, let's just write. Right now we have written in the form of pictorial. Let's just write first one. What he is doing, he is changing the bulb, color of bulb of everyone. So let's just write the serial number of the bulb, which state he is changing, so on. So he will go do. So what the second person, this is the first person, the second person, and the third person. Let's take these 3 digits and try to start with the smaller number, so that we can easily understand the concept, or if not the concept, then we can understand the pattern. So second person will do second, 4, 6, 8, 10, 12. Okay, until it will go at 100. This third wala, how he will do 3, 6, 9, 12, 15 till 99. So what I can see, what I can find a pattern, that everyone is changing, or let's just take more examples so that it's easy. 4, 5th, 6th. Okay, let's take 4. So 4, 8, 16, 24, 28, so on till 100. 5th, 5, 10, 15, 20, 25, 30, so on till 100. So 6 wala 6, 12, 18, 24, 30, 36 till 96. 16, 6 and 96. After that it is 102. So what I am checking over here, or let's just take till 8. A pattern will be visible. 7, 14, 21, 28, 35, 42, so on till 98. Right? 8, 16, 24, 32, 40, 48, so on till how much it will be? 96. So yeah, 96 only. 96. So what I am seeing, let's just take the example of sixth wala bulb. So sixth wala bulb, how many times it is changing? 1, 2, 3. Okay. So for example, sixth bulb changes 3 times. The state is changing 3 times. Okay, great. Let's take fourth bulb. Why I am taking only 3 times? Because after this 9, 10th will come, they will not going to bother this sixth bulb. Okay, for the fourth bulb, how many times it is changing? So fourth bulb will be changing here. Okay, here also na, here also 6, so 1, 2, 3, 4 times na, it will be coming 4 times. At which one? First, these people will come and change, right? 1, 2, 3 and 6. So similarly for fourth one, who are changing? It will be changing 3 times. So 1, 2 and 4, 3 times. 1, 2 and 4. Okay, great. Let's take any example. Let's take fifth bulb. how many times it is changing its state? So that would be only 1 2 times, that is 1 and 5. Let's take eighth bulb. Eighth bulb, how many times it is changing? So 8 8 8 and then 8. So 1 2 3 4 times. 4 times it is changing. So 1 2 4 8, these are the places. So one thing, if I see that if it is changing even number times, so suppose that one bulb is off, so first time it will change, it will be coming on, right? It's turned on. Second person will come, it will turn off. First person, second person. Okay, I'm just saying person, I'm not talking about which person. Third person, if 3 people are coming or 3 times it is happening, so it will change. What I can say, from initial, if odd times it is coming, then it will change. Okay, odd times, either first, third, it will change the state from initial. And similarly, if it's even times it remains same from initial. Okay, this is what I could understand as of now. So till now we understood that how is change happening, okay, and how it remains same. One more thing, if I notice over here, that the sixth bulb, 1 2 3 6, these are the factors, prime factors. Okay, for fourth, what are the prime factors? These are also the prime factors. For fifth, also factors. Also eighth, for also factors. So for our first question, that is being asked, that how many times these 100 bulbs would have changed the state of the 90th bulb. So the first will be, how many times 90th bulb, this is the question. So 90th bulb, first of all we have to find the prime factor of 90. 1 2 3 4, no, 5 6, will it be there? Yeah, 6 15 6 and 90, 6 7 8 9. Okay, now we just need to multiply by it. See, once we reach to the middle, now we need to do is, whatever we have written over here, we'll just have to multiply, divide this number with 9. So next prime factor will be 10, next prime factor 15, next prime factor will be 18, next prime factor 30, next prime factor 45, next prime factor 90. So how many times these are the prime factors? So how many times it is changing? So 1 2 3 4 5 6 7 8 9 10 11 12. So the answer of the first question will be 12 times. 12 times it is changing. So the question, what is the question? Let me read the question. How many of these 100 people would have changed the state? So how many people would have changed? So it is asking about the people. So if the question is about the people, it is 12 people. Or if it is asking whether it will be changing or not, so even times, so it will be remaining same. Okay, how many of these 100 people would have? So the answer of the first one is 12 people. 12 people answer. So the first question is completed. So the second question, let's read the second question. What is the second question asking? At the end of 100 operations, so 100 operations have been completed, how many bulbs will be switched on, assuming all the bulbs were switched off initially? So if all the bulbs were switched off initially, what is the question? So B number question, all bulbs switched off initially. This is given in the question, assuming this one, and the question is asking that how many bulbs will be switched on. So bulbs switched on. How many bulbs switch on? How many bulbs switched on? This is the question. So if all are off and it is becoming on, so the prime factor should be the number prime factor should be odd times. So odd times, all the odd times we need to find. So what I can see in this condition, what I saw, or let me just visualize that while finding the value of 10, what I did, I patch up 9 and 10. Okay, to find the value of 6, I patch up this value. For 5, I patch up this. For 3, I patch up this. For this one, I patch up this. For this one, I patch up this. So any number, a number x, if I say that if for one is the prime factor, so next one will be x. Okay, then if I say 2, then x by 2, or x by 2 should be, suppose I'm just taking example, like, okay, let's take example of 10. So 1 and 10, this is also prime factor. If I take 2, 5 is also prime factor. That's all. So what I am saying, that it is having a pair. But if there is a number like 9, so what is happening? 1, 3, 9. So in this case, 1 and 9 is becoming the pair, but 3 is what is repeating. And if this is repeating in which numbers, it will be only possible. So odd times will only be possible in terms of perfect squares. Let's take any perfect square. Let's take 49. So for 49, 1, 7 and 49, I suppose these are the only 49, right? Yeah, there's nothing. Or let's take any number, well, not in for 25. Let's take 25 also. 1, 5, 25. Okay, so this is not true. Let's take 16. 1, 16, correct. 2, 8, right. Then 4, only this is left, right. This is the condition in every squares. Let's take 64. 1, 64, right. 2, 32. 3 won't be divisible. 4, 16. 5 won't be divisible. 6 won't be divisible. 7 won't be divisible. Only 8. So here it is, because it is even, so even it is written over there, even remains the same, even remains same, but because of this person it will be changing. So how many perfect square are till 100? So 1, 4, 9, 16, 25, 36, 49, 64, 8 na 81 and 100. So there are total of 10. So the answer of B will be total of 10. The answer of B is total of 10. 10 bulbs. 10 bulbs. Okay, so these two questions have already been completed. So coming to the next question. So third one, I think it's better if I just bring the question also over here now. Let's copy this question, because we have already understood the concepts. Now we just need to understand the question and solve accordingly. So the question is saying that if the operation would have been stopped when the 50th person completed his job, okay, and how many bulbs would have been switched on? Okay, so when the 50th person completed the job, then they stop. 51st person will not going to come and do anything. Great. assuming all hundreds were switch off initially. So initially it will be switched off. So the question asking, what is the question asking? How many bulbs would have been switched on? So the question asking switch on. So first thing first, if suppose that this is the queue, this is the passage, okay, this is the first bulb, this is 100 bulb, and somewhere in the middle it will be 50th bulb. So what is happening? So first person is coming, first person turning on 1, 2, 3 and everything. Second person won't budge about first one, he started with second and just do. Third person won't budge about first and second, likewise. So I can say if 50th person will coming to bother about this one, and from the 50th person will budge about this one, okay, and after 51 there will be no one. So 51, 52, like it will be there, but after 50th person is done now, so 51 will not be going to do, and after 51, 52 will also not going to do, 53 also not going to do. Till 50 everyone is going to do. So first thing first, let's divide it till 50. So the thing is, if it's a normal one, so how many bulb would be switched on? How many bulb would be switched on? So can I say, see what is happening over here, let me try to, suppose here is 49 bulb, okay, so this 49 will be turn on and turn off by first person, 7th person and 49th person. After that, if the 51st person is going to come, he won't going to bother about all these bulb, he will turn on this one or turn off the state and he will go. Just like the last 100th person, he is not going to come because we have already stopped after 50% chance. This 100% didn't get the chance to come and turn off and turn on, he didn't get the chance. So what I can say, till 50th person everything has gone normally, but after 50th I'm not sure what is going to happen after in this domain, because till here I know 50th person come to till this much everything has gone easily. So question is switched on, switched off to switched on, which means only one thing. Where is it? Change. If change, odd times, and odd times only comes where? Odd times only comes in the perfect square. Odd terms only comes in the perfect square. So I can say till 50th, till 50, switch on bulb will be 1, what are the squares? 1, 4, 9, 16, 25, 36 and 49. Only these are switched on. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7. So 7 bulbs will be switched on. Okay, but what is happening afterwards? What is happening afterwards? That we have to focus. So previously what used to happen, that the next hour square used to be 64, right? Next hour square used to be 64. I'm just taking for an example. So it was used to be turn off and turn off by whom? Let's write 164, 2 32, 4 16 and 8. So right now what I can see, first is switch off, first person is coming, second is coming, fourth is coming, 8th is coming, 16th one is allowed, 32 is allowed, but 64 is not allowed. Why not allowed? Why not allowed? The reason why 64 is not allowed, because after 50th person we stop people from going onwards, because this is the place where every majority of people used to make mistakes. So that's why I'm stressing. So this is why. So how many times it has been changed? So 1, 2, 3, 4, 5, 6. So 6 times. So previously it used to be 7 times, which means that bulb state is changed, but it's 6 times. So bulb state no change. No change. And this is for not 64. After all the perfect squares, let's take example of some other number, 51. So 51, how it will be? 1. Let's take example 1, 1, 51 and 3, 117, right? 117. So what is happening over here in this condition? 1 is allowed to go, 3 is allowed to go, 17 is allowed to go, 15, 1 is not allowed to go. So how many times it is changing? It is changing 3 times. And now what previously it used to be changed 4 times. 4 times is no change, but now it is changing 3 times. So it will be change the state. So now everything has turned the table. Everything has now started turn the table. So in this much, how many are there? Total of 7 bulbs. Okay, and in this much, how many are there? 50. All the 50 minus all the squares which are left. So how many squares are left? Because squares are not changing now. Squares are not changing. What is changing? All numbers except a square. So 50 numbers minus first one will be 49, 64, 81 and 100. These 3 numbers. So minus 3, 47. So let's just write 47. And total will be 7 plus total will be 7 plus 47, it will be 54. So the answer of the third question is 54 bulbs. Okay, let's copy the last question. Last question. Let's solve the last question. So if the 50 bulbs were switched off and the next 50 were switched on, 50 off, or let's just use the same analogy what we did. So this is a line, this one. So initially 50 off and here 50 on. Okay, then at the end of 100 operation state, how many bulbs remain unchanged? So again the same concept, unchanged. So unchanged will be for which one? Unchanged, we have already said, remain same. Unchanged is remain same, so even times, right? Unchanged. This question is talking about unchanged. So if it is unchanged, how to approach this question? See, where is it? In the beginning we have done, na? So for change, odd times, for this one even times. All we know that for even, if I want to remain same, then even times. Okay, and the question is talking about with the first initially at the end of the 100 operation, how many bulb unchanged? Unchanged means remains same. So remain same, right? Let me check. Remain, oh sorry, I went too far. So remain same, where is it? Remain same, that is even times. And I know even times and odd times is perfect square. So total minus remain same, so I can say changed will be remain same. So total is how much? 100. Well, let me just complete in that page on itself. The total is how much? 100, and changed in terms of 10. So 90 will be answer. The bulbs which are not changed, I don't need to focus upon which 50 or not. I just use the initial concept and solve the question. So the answer of the last one is 90 bulbs. So yeah, this question is also done.